I will keep it honest and transparent. So a situation like this, log, let's say 2 to the power 14 plus log 2 to the power 18 equal to, let's say, log 2 to the power x. I was saying that we can cancel this, this and this. This is not correct.
You only cancel out two things?
Yeah, you can only do multiplication or division. I mean, it's called, there's a term for this. So here, it's always like this. So I'm recording my mistake, okay? And that's okay, because no, we can learn incorrect thing, but we have to fix it sooner. If I have something like this plus this only means this is when you have a plus, this only means multiplication. You cannot just look at the base and cancel out things. You can cancel that, okay, this and this gets cancelled. But not in a situation like this. This will be a crime. If you do that, I will just navigate through by teaching you something wrong, but it will impact you. Okay, so this is a mistake that I want you to correct, which I injected. So, simple thing is, there are three formulas that we need to be aware of. Let's say log x a plus log x b equals log x a into b. This is one. Log x a minus log x b equals log x a by b. And third one is log x a to the power b equals b times log x a. Okay? These are only three formulas that we have to keep in mind from a log perspective. And there's one more thing that we know or we need to know for log is changing base. So let's say if I have log x a is this one is fine. I need to change the base. Then there's a way to write an equation. I just woke up, I was lying down and I probably just 1 second. this is called log change of base. So that is okay. So if I say if my log of A base B, I can change the base. I can write this as log 10, let's say, base A by log 10 base B. This one also I can do. So if I have something, let's say, in the form of a log with a different base, I want to convert this into, let's say, log base of 2. I can always say this. I can convert this into a base of 2, where this will be my numerator and this will be. So here I can change the log, I can change the base of the log and convert into a different value actually. This will be helpful whenever we are dealing with. This will be helpful whenever we are dealing with any situation when we have to change the base of log. We will come to that. So there are two things that we want to correct. One is the base formula or base approach, right? One is when you are multiplying two logs, that gives you a plus of it, right? That's called product function. Second is when you are dividing two logs, that gives you subtraction. That's called, you know what is that called? There's a name for that function. It's called, I just want to make sure that I don't tell you something which is not correct. Log functions. Log functions. There you go. I'm missing something. Okay. Product function, power function, and division function. Okay. So one is called product function. Which is log A in plus log B equals to log AB. My base is same. Second is called division function, which is log A minus log B. Base is same, is log A divided by log B. Yeah. And third is called power function, which is log x to the power n equals n into log x. Yeah. So these are three functions that we know, and the fourth one is the change of base. So that one is, it is as simple as it looks. Log of A base B, you can convert that to a log of a different base, and that is how you will change this. Now let's look at some of the sums, okay, that we were doing yesterday. I don't want you to go wrong. Let's pick another one. So can we look at some of the sums and try doing it? Yeah, let's pick up some of the sums. I want to do it quickly so that we do a recap of what we have learned, and whatever mistakes we had done yesterday, we can correct them.
I had a question on one of the sums.
Yes, that one will come to. So that was the natural logs, right?
Yeah.
When you talk about natural logs of something, let's say x, this is just the basic part, okay? This is not different from the logs. Only difference being here natural log is, I can also say this as log to the power to the base b. Yeah, and this e is a number which is not a fraction, not a whole number. It's called an irrational number whose value is what, 2.17 something. Okay, so this is it's an exponential number that is used for for logs where the base is different. So we'll not worry about the value of it. Only thing that you have to remember is the natural log is a scenario where it's a log but base e, and e has a value which is a non-fractional number. So we'll come to that sum also. Let's pick up another basic one quickly, and any other sum that we did yesterday.
Okay, log 3 base 3.
What is that?
Wait, no, hold
Log.
on. Log base 3 in parentheses
Okay.
2x plus 1
Okay.
equals to 2.
Yeah. Equals.
To just 2.
Equals to. Equals to. So, like what we were doing, this 2 can be written as this, and since my base is 3, I can always write this as 2 into log 3 base 3, or I can write this as log 3 squared. Yeah. So this is my equation. Now my equation becomes log 3 2x plus 1 equals log 3 squared. This is my equation. And this is, at this point in time, we can cancel this, okay? Not like the way we were doing yesterday. I mean, like how I was doing yesterday. That was wrong. I was feeling actually guilty for teaching you something wrong. Okay? So this is 2x plus 1 equals 3 squared, which is 9. So 2x plus 1 equals to 9, x equals to 4. This will not go wrong. So I'm just doing a okay. Now, any other question that we want to pick up before we go to the natural log one?
Yes. 12 in parentheses, and then parentheses 1 minus 4 to the power of x.
Okay. I think you see the question.
35.
12, okay, 1 minus 4 to the power x equals to 18. Okay. One minus 4 to the power x is 18. Now, what we can do is, let's simplify this first. So this is 12 minus 12 into 4 to the power x equals 18. Yeah. So it becomes let me see the equation one more time. Okay. So this is where I was going wrong without using this. 12. Okay. What is that?
I solved it and it said no solution.
No solution.
But I don't know, like, how do you know if something has no solution?
Something is no solution if you come across a situation where it becomes an equation like, let's say, 15 minus 6 equals to 8. There is no variable. If you have an equation like this, that is when, or it could be just any number which looks meaningless. It has no solution. If you have something like x equals to x, this is a situation when you have multiple solutions. For every value of x, there is a corresponding x. So, if you go back to the unit 1 that we started with, okay? When we are solving equation, there are two scenarios that you come across. There are three scenarios. When there is only one solution, when there is no solution, and when there are multiple solutions. That we covered in the first unit actually. Just go through that whenever you get time. But in summary, you will have no solution when there is no variable. You don't know what you are solving for. So if you, let's say, I'll give you a situation like this. 12 plus 3x equal to something plus 18. And you can convert this equation into an equation with no solution by putting a 3x here. Now, this and this will get cancelled out, right? I mean, when you do calculation, this and this, it becomes an equation 12 equal to 18. This is an equation with no solution. So basically, in summary, if you get the variables eliminated, or when you don't have a variable in your equation, that is when you can say there is no solution. Okay. So now let's look at this guy first. Let's try solving this one. It says 12 1 minus 4 to the power x equals to 18. And if I convert this into, let's say, log of base 10, 12 into 1 minus 4 to the power x equals log of log of 18 base 10. So I can say log of 10, 12 plus log of 1 minus 4x equals into a log, first of all. But if you don't be converting into log in the first place, what we should do is first try simplifying this. So 1 minus 4 to the power x equals 18 by 12, or 4 1 minus 4 to the power x equals whatever, 1.5 or whatever it is, or 4 to the power x equals minus 1, minus 0.5. Now, did you get this one?
Oh yeah.
This is,
But wouldn't it be negative 4? Because
so now it will be 4 to the power x is equal to minus 0.5.
oh,
And this is where you come across a situation where you will say that this is not possible, right? Now you look at a couple of scenarios, okay? Any number to the power anything. What does a x to the power 0 mean? I mean 4 to the power 0. I mean, let's say if you are looking at x equals to 0, what will this be?
1.
It will be 1. This is not possible. If you look at x equals to 2, this is also a situation where this is not a matching solution. This is a scenario of no solution again. Now, if you look at x to the power minus 1, what it becomes? 1 by, so 4 to the power, okay, 4 to the power minus 1 is what? Equals 1 by 4 to the power 1, right? This is what we learned. And this becomes 0.25. Net, what I'm trying to say is, regardless of whatever number you put, it will never become negative. Any number to the power something will not convert into a negative. Am I? Yeah. Any number. You pick any number, okay? You pick any number which is positive. Any number which is positive, okay? And put any power to that. Then also it is 1 by 5. It will not become any number which is negative. So the scenario that you have is any positive number to any power cannot translate into a negative value. Even if the power is negative or positive, whatever it be, it will always be a positive number. That is why it's a situation of no solution. Now you tell me how did you get to that answer? What was your approach?
I just tried solving it and then I got log to the base of negative 48, 1.5 equals x.
Can I see that?
Yeah.
I'm just trying to make sure that your understanding and my understanding is similar. This one, right? Did you try solving it? Okay, 12 minus 12 into 4 to the power 8. No, this will not be correct. See, if you have a number, you are multiplying by this. It will not be 12 into 4 to the power x. This will not be 48 to the power x. It will still be 12 into 4 to the power x. Like, okay, let me show you an example. Let's see, I have 5 into 2 minus 3 to the power 2. Okay, let's see if I'm multiplying this. I'm kind of getting old now, my classes don't work. Okay, so if I have to multiply this, okay, I will say 5 into 2 minus 5 into 3 to the power 2. If I take the other approach, if I say 5 into 2 minus 5 into 3 to the power 2, these two are not same actually.
Oh, yeah.
Yeah. So that 48 will not be correct. But yeah, answers will match. Give me this one. So see here. Here let it be 14 into 4 to the power x. Everything remains the same. You did this and you found that. Okay, let me convert this into log the way you have done. See, this same problem can be solved in two ways. First, like what I was doing here. So 12 into 1 minus 4 to the power x equals 18. This was the question, right? So I will say 12 into 1, 12 minus 12 into 4 to the power x equals 18. That makes it minus 12 into 4 to the power x equals to 18 minus 12. Yeah? You need water? Yeah. Don't be shy. I call you. Yeah. See if this is good enough. You want it to be cold? It's good? No. So this becomes minus 12 into 4 to the power x equals 6, or minus 4 to the power x equals 6 by 12, which is 0.5. Now I can say 4 to the power x equals minus 0.5. Okay. Now let's make it value base 4. Yeah. So I can say this log if I take base as 4, right? So log 4 x equals log 4 minus 0.5. Yeah. Okay, now my way. So I will convert this or use log base 4. Okay. If I do that, it becomes log 4 to the power x equals log 4 minus 0.5. Okay, and this becomes x log this thing, right? This is what it become, right? Like if I say log 10 base 10 to the power 2, it becomes what? It becomes 2. Yeah? So it becomes, so that's what I'm saying. So x equals log of 4 minus 0.5. And do you have an answer for this one? I mean,
but I can put it into a calculator.
Yeah, just check. No, I mean in the wherever you had the question, right? You would have been. They would have given you some answer for that also. This question, right? Can you verify that?
They said it was no.
It's a no answer thing, right? That's what I'm saying.
Yeah,
So
it says like.
Yeah.
I think that's why it's a no answer.
Log 4. Yeah. See, log 4. I mean log minus 0.5 base 4. And what does it mean? This one? Okay. But this is a calculator. You are calculating it right now.
Yeah.
Yeah. I'm saying if you look at the answer sheet and see what does the answer sheet say?
The answer sheet said no answer.
No answer. And this is the answer for that. Okay. This is the reason for it. So even if you don't do logs here, okay. Even if you don't do logs, if you compute it here also, okay. See what we got was x equals log of 4, log of minus 0.5. This is a situation of no answer because we have just converted that to a log, right? Now keep it here. If you start with this place itself, any number to the power, what will be the power? Okay, be it a negative number, be it a positive number, be it a 0, it will never give you a negative value.
So then it's no solution.
So this is where you will say this is a situation of no solution, because this is the equation we are getting into, and by no means, by putting no value here, you can get a negative value. So for no value of x, you will get a negative. That's what it means. This is a situation of no answer. Okay. Let's pick up another one, and just to be doubly sure, and then we will go to. So, okay, good that Daddy is not here. I can ask you something, what do you call, with confidence. So, Daddy called me yesterday saying that, it's regularly recorded, but there's nothing confidential. He said that there's some confusion you have with the logs. So, is this what we had confusion about?
Yes.
Or was it because I taught you something that got you more confused?
Oh, no.
I mean,
I just had another question because I did more practice problems.
Okay.
And then that was this one.
Okay.
That was the one that we just did.
Just did. Okay. So then we're right track. Okay. All right. Yeah, because he called me in the evening and I was worried that is it because I taught something that got you more confused, or is it? Okay. Good. All right. So let's pick up one more sum and then we'll go to that the natural log thing.
I haven't done any other.
Okay.
Like more sums.
In the notebook, just randomly pick any other question that you have. Any question randomly. And I would want you to do it because.
Okay, 10. I mean 134. 100 e to the power of negative.
Can you read it?
100 e to the power of negative.
Let me read it. 100 e to the power 0.6x equals 20. 100 e 100 e to the power
Negative.
0.6x
Yeah.
equals
20.
20. Okay, let's keep it simple. E to the power minus 0.6x. Let's keep aside log and everything, okay? Log is what do you call an opportunity for us to simplify things, okay? If it doesn't simplify, we'll not use it. So we'll keep it simple for now. Let's see. Equals 20 by 100. That means e to the power minus 0.6x equals 0.5. Yeah? Uh,
0.2.
Yeah, my bad. Okay. This is okay. Now we can convert this into. See, this is the e that I was talking about. ln is nothing but log to the base e. Okay.
So ln.
So we can say ln
0.2.
e to the power minus 0.6x equals ln, or I will keep it simple, I will say log e 0.2. Yeah. Here this is ln or log e, so this becomes minus 0.6x equals ln or natural log of 0.2. Yeah. Can you find out what is the value of this in the log table?
ln.
Yeah. Or log base e. Log 0.2 base e.
It's negative 1.61.
Negative
1.61.
0.61. So that means minus 0.6x equals negative 1.61. That is x equals 1.61 divided by 0.6. These two get cancelled out and this will be the answer. 1.61 divided by 0.6.
It's 2.68.
Yeah, whatever. Can you check if that is what the answer says?
Yes.
Yeah? So very good. So just any sum we do, right? I mean, I have not done or played with these sums for us, let's say 30 years now. Yeah? 30, 32 years. So if I'm doing something, if I go wrong somewhere, like you pointed out, I made this 0.5. This is the aging problem. Okay? So always, whatever I teach, right? See, I will always try to make sure that the underlying concepts are correct. And when you use those concepts to solve the problem, you should be able to do it with ease. If you are getting stuck anywhere, we'll redo the concept to make sure that we are not missing something. If you look at this sum, what did I try doing? Though it looked like it's a question coming from logarithm, we tried sticking with the basics of math. Okay, 100 into this is this. So let's simplify this. Let's see if we can solve this with a normal calculation. And this is where we came to a point where, okay, now we have the option of remembering the value of E, which is 2.17 or something. I don't remember exactly. Or say, okay, fine. E happens to be my base for the natural log. Let's use that. And we apply log on this one. We say, okay, log on this side versus log of this side is this. So since here in case of natural log, my base is E, so this gets simplified to this value, right? Normal thing that we know, right? Log of a to power x is equals x, because this is my base. So same thing here. This is log log of this base E, and that is simplified to this, and we form the value for this and that. So we'll use the basics always, unless it requires or forces us to do something cryptic in nature. Let's look at the natural log problem that we had noted down yesterday. So number 17. I mean, honestly speaking, I have not tried solving it. I just thought, okay, let me make sure that we revise at least I revise the concepts, and then we'll try using the concept for solving it. Let's see how close it gets.
4ln.
Okay, 4 of natural log 2x plus 3 equals 11. You have to solve it for x. Okay. Okay. Now what does it mean? 4 of log 2x plus 3. We can always say natural log of 2x plus 3 to the power 4 equals 11. Yeah?
Yeah.
Now, what does this 11 mean? 11 means 11 into 1 or 11 into natural log of E, base E.
Is that thing?
Yeah? Can I do that? Can I say 11 is 1, 11 to 1, or this is natural log of E?
I think so.
Yeah? That means this is natural log of E to the power 11. Yeah? That is, my equation becomes natural log of 2x plus 3 to the power 4. Or why I'm complicating this always?
Wait.
let me try simplifying this first. Okay, this is my equation. This is my equation, right? 4 in this. I'll say natural log of 2x plus 3 equals 11 by 4. Yeah?
Yeah.
Yeah?
That's fine.
Yeah. No, I was complicating it.
No,
So-
I think I understand it now. I think. Wait, I'm gonna try something. And see.
Yeah, you try something. I mean, this is no different from the basic concept that we have learned. I'm just trying to solve it. Okay? This gives me 4 to the 8.
Let me check the answer. Yeah, I got it now. Yeah, that's
Same
what I
thing?
got. Yeah.
Same thing?
Yeah.
So, the same thing, whatever we did so far, it affirms that any problem that we deal with becomes simpler when you keep hitting it hard.
Yeah.
Like it's like a sandbox which is very tight, and you're doing boxing practice. Okay, I don't know. I have never done boxing practice, but I'm just giving an example. So if you keep hitting it, keep punching it, right, you'll see that after 7, 8, 10, 15, 20 times, depending on how much force you're applying, it starts becoming loose and no, more malleable, I mean softer. Same thing with the sums. If you keep reading it over and over again, I don't think we have done anything magical today. We made a mistake yesterday, okay? I mean, I made a mistake. And that is where things were looking complicated. Only thing that we learned extra was that whenever you talk about natural laws, there's nothing complex about it. It just changes the base. It uses the base as E. That's it.
Yeah.
So, only 3 formulas: the product formula, the division formula, and the power formula. These 3, if you remember, whole log works. We don't have to memorize the log table anyways. We have it in calculator as well. So that is one thing. And then if you have to change base of log, I don't think we had any question with that. But if you come across a situation where you have to change the base of this one, you can change the base this way. And this looks okay to our eyes. Same way, right? I mean, this is looking like a numerator, this is my denominator. That's how I'm converting. I'm just using the same base. So if I have to change the base of something, this is what I can do. And we can use this if needed for the natural log scenario also. You can convert this into say, okay, fine. I will not use 10, I will use E as my base. And that is how I can also say this is natural log of B by natural log of A. You can literally play with this. So, only thing you have to keep in mind is the basic concept, the base concept, and then after that, whatever you do is based on what you want to do. Okay. Now let's see if there is any other confusion, any other question that we have related to logarithm for your test, or we have at least 10 more minutes. If you want to pick up any other sum, do the practice for that, we can do that.
One last one.
Mm-hmm.
Let me find it. Okay. 2 instead of 12.
It says 2 e to the power 2x minus 5 e to the power x minus 3 equals 0. We have to solve this one. Now, here look at this guy. Let's read this guy again and again. This is E, something similar to the natural log that we can use, right? That's what it looks like in the first view. Okay. This guy is a constant, the only outlier. I can always change this. I can bring this that to one side, yeah?
Yeah.
Because there's one more thing that has to go in the back of your mind. That if I'm doing multiplication or division, I would not want to do with 3. There's 3 negative, right? I don't want to do with 3 divisions. It might get confusing. So let me keep the variables on one side and the constant on the other side. This is the first thing I would want to do. Now, if I want to convert this into a log, what will I do? See here, e to the power 2x, this is e to the power x, okay? Let's convert this into a log. So here if I apply a log, what that will, okay. Let's take out the common things here. Is this correct? The first one? Does it look correct? E to the power x, see this is like, I'm breaking this into 2 parts.
Oh, okay.
Yeah? So it's like x to the power 1 into x power 1. That makes it x to the power 1 plus 1. Same way here, keep aside the constant part, e to the power 2x, I can write this as 2 into e to the power x into e to the power x. Yeah? So I just took out the common things here. Now this is in the form of a multiplication. So let's do this. Now let's take a log of this. Log of, I'll use natural log. X into, so this will become natural log ex plus natural log 2 into e to the power x minus 5 equal to yeah. Okay, my bad. No, yeah, this is fine. Yeah. Here, this becomes natural log of e to the power x becomes x for me. Yeah?
Yeah.
Plus natural log of, now I'm just thinking, if I apply a log here, natural log, in this scenario, I'm just afraid of making a mistake like this. If I apply a log of x plus y, can I say this will be log of x plus log of y? No, right? This will be wrong. Because this formula says if I use log x plus log y, it becomes log xy. So I cannot just split this like this. This is not correct. So how I can simplify this is what I'm thinking. I will take a different approach. Okay. So I will try solving this like a mix of quadratic equation and log function. So let's assume here e to power x equals a. Okay. If I say this is a, this is a squared, 2a squared, because e to power x is equals to a. If I say e to power x into e to power x, that becomes a into a, and here e to power becomes x plus x equal to e to power 2x.
Yeah.
So I can say this is a squared.
Yeah.
Yeah. Minus 5a
Yeah.
minus 3 equals 0.
Oh yeah.
Now I can find the value of a by solving this quadratic equation, right? So this is 2 3s are 6. So 2 into 3 minus 6. I have to get a minus 6 here. So I can say 2a squared minus 6a plus a minus 3. I'm just breaking this into. So here I'll say 2a common, a minus 3 plus a minus 3 equals 0, or 2a plus 1 into a, what is it, minus 3 equals 0. So 2a, yeah, Ishan, pick a chair, sit down, we'll start in a minute. 2a plus 1 equals 0, or a minus 3 equals 0. Okay. So a equals to minus 1 by 2, or a equals to 3.
Yeah.
Now a, there are two values of a that we have got. And what is the a? E to power x is a. So the value of e to power x is either minus 1 by 2 or this is equal to 3. Now you can apply the natural logs and find out. Here you will have two answers for this one.
You have to plug it in, right?
I'm sorry?
You have to plug it in.
You have to plug it in. You have to plug in the natural logs and then get the value. So here, now you have got two values for e, right? Because we can see this. I was kind of, when I was going through it, it was making it more complicated. What I did was, I simplified this. I have to find. This looks like a square. This is a. So 2a squared minus 5a minus 3 equals 0. Can I solve it like a quadratic equation first? Get the value for this. Yeah? And once I have the value for this, I know a is nothing but this. This is what we had assumed. So I have got two values. I'll solve, I'll plug in the natural log for this one, get both the values, and that will be my answer. Just try plugging in this one and see if it is matching with what you have in the answer sheet. Summary is, I was getting confused, trust me, when I started this. And then I was kind of getting confused between the plus and minus sign, the operation, because the natural instinct is you'll get tempted to use it like a plus or minus, addition or subtraction. But that is where you could go wrong, because the logarithm says that log a plus log b equals to log a into b. I cannot say log of a minus b equal to log a minus log b. That will be completely wrong. So that natural instinct of doing operation, you have to control there. So that's why I tried simplifying this like this, and then I tried solving it. So whenever you are seeing a difference in power, you might want to go a little careful there. Don't go by that natural instinct that okay, log x minus y equals to log x minus log y. I cannot do that, because the time I do that, like a natural bracket, my logarithmic functions basic construct gets impacted actually. So that's the only care you might want to take. Okay. So try solving, try substituting the value with these two and see if that is matching with the answer we have. If not, ping me on WhatsApp, not on Telegram, because Monday to Friday when I'm working, sometimes the telegram message comes with a delay. Since my WhatsApp is working, just let me know, and probably post office hours. Now if there is some confusion, we can just connect for 5-10 minutes and solve it. Okay? Alright? Does this help?
Yes.
Do you feel better for the exam?
Yeah.
Okay. I'm feeling better too, because I was